All right, good morning, everyone. We are looking right now at topic 9 notes. We're looking at the page that says dilation up at the top. Okay, dilation, this is a one page section of notes, so it should go pretty quick. So we're going to start by talking about dilation, the definition of what it is. Okay, first off, it is a transformation. Okay, so this is stuff that kind of goes along with topic 8. Okay, topic 8, remember we talked about different transformations like reflection and translation and rotation. Well, dilation is another thing that you can do to an object that is sitting on an XY plane. And what it does is it produces an image that is the same shape as your original, but is a different size. So if you want to think back to what we've talked about earlier in topic 9, you could say that if it's the same shape and a different size, a dilation produces an image that is similar to the original. Okay? Similarity, same shape, different size. All right, so there are two types of dilation that you can have. You can have an enlargement, which is when you have a scale factor that is greater than 1, and it creates a larger image as you would expect it to. And the other type of dilation you can have is a reduction. And that's what happens when you have a scale factor that is between 0 and 1. So, what that means is that is a fraction or a decimal that is smaller than 1. Okay, I will say this too. You'll notice that neither of these options gives you a negative number, right? And it never gives you 0. If you have a scale factor of 0, then you're not actually multiplying times anything and nothing changes. If you have a negative scale factor, you did something very wrong. Okay, you got to think about this. Everything that we've talked about with a scale factor changes the distance between 2 points. Okay, it changes the length of a side, and it would not make any sense to end up with a negative length of the side of your shape. Okay, that doesn't make any sense to have a negative scale factor. So you either have a larger number greater than 1, or you have a smaller number that reduces the size of your picture, and it'd be a fraction or a decimal. And that creates a smaller image compared to your original. All right. So we've got a couple of examples here of what this looks like. And there's something to fill in to the right of the graphs. It says if the center of dilation is the origin, 0, 0. And today, all of the dilations that we're looking at are going to be using the origin as the center. Then all you have to do is multiply the coordinates times the scale factor. All right. It's very, very simple. And it tells us on here that our scale factor is 1/2. So what we're going to do is we're going to look at our coordinates. Okay, our original coordinates are 2, 2, 4, -2, this one over here, -4, -2, and -2, +2. Okay, that's our 4 coordinates on this, which is a trapezoid. Okay, the shape on our original graph is a trapezoid. And so what we're going to do with a scale factor of 1/2 is we're going to take those coordinates and multiply everything times 1/2. So +2 times 1/2 is 1. +2 times 1/2 again is 1. So our new point there is going to be 1, 1. Let me use a different color. It's 1, 1. There we go. We're going to do the same thing all the way down. All we're doing is multiplying everything times 1/2. So -4, so +4 and -2 becomes 2, -1. That's our next point. 2, -1 right there. Then we've got -4, -2. Cut everything in half. -2, -1. And again, our last one, we cut everything in half. And it's -1, +1. All right, let's see if we can't get that new trapezoid on here. And you'll see right there that we've cut all of the side lengths in half. You see on our original how we had a length of 4 going across this top piece of it. Well, now it's only 2 units long. Okay, so it is just like we found this shape with a scale factor of 1/2. We went from our original to our new one, just like that. And all we did was by multiplying the coordinates times the scale factor. That's all it was. It's an exceptionally simple idea. And this right here would be an example of a reduction. You can see our scale factor is a fraction that's smaller than 1. And so we should end up with a new shape that's smaller than our original. All right, take a look at this next one. This time we have a scale factor of 2. So if you're thinking about it, our new image that we put on this graph should be larger than the one that we started with because this number, our scale factor, is larger than 1. So again, this is just the same statement. If the center of dilation is the origin, all you do is multiply the coordinates times the scale factor. So here's our original coordinates: 2, -3, 0, 3, and -2, -3 down here. Okay, we're multiplying everything this time by 2. So when we do that, we end up with new points. Multiplying times 2 is 4, times 2 is -6. So 4, -6 is one of them. 0, +6 is the other one. Remember, if you're multiplying 0 times 2, it's still just 0. And our last one, -4, -6. And we can put all of those points onto our graph pretty easily. Okay, this is not exactly the most difficult thing we've ever done. All right, all that's left is to put our new our new line segments on there, and we will call it a day. And there we have it, our new image, which is scaled up by a factor of 2. Okay, it is enlarged by a scale factor of 2. So there we have it. That's all we have for the notes. I told you it was going to be a short one. And there are some Canvas problems that are some review from the rest of Topic 9. And there's only a couple that are about dilations. All right. So if you have trouble, please let me know. And also, y'all have a nice day.